Here we have a piece of elastic that can be stretched to 1.5 times its original length. And when fully stretched, it is 12 meters. What is the elastic's original length? Here's some of the look fors in the problem is that we have presumably this elastic that when stretched 1.5 times is 12 meters long, and the label would be in meters. So presumably this elastic, when unstretched, which it is, we don't know its length, but when stretched, the stretchy material has a length of 12 meters. So here I'm going to use a bar model to solve this, and I'm going to first begin by representing the 12 meters in length. So I'm going to draw 12 boxes, and I do this efficiently. And the boxes look pretty even. Right underneath it, I'm going to draw these 12 boxes again, because this is the one that I'm going to play around with to get my final answer. So once I have my 12 boxes, one box representing each meter, I need to keep in mind that the elastic is stretched to 1.5 times its original length. And I know 1.5, when turned into an improper fraction, is 3/2 or 3/2. So I'm really looking for groups of 1.5 within the 12 meters or groups of 3/2. So every 3/2 I'm going to mark it off on my bar model. So what I have to do is I then have to take each meter and break them into half. That way I have halves to work with. Once I've broken them into halves, for every 3 I count off, I'm going to mark it. And if you just look at the first group, I have 3 boxes which make my group, but these 3 boxes are worth 1.5 meters. And when I'm done, I can jump and count how many groups of 3/2 I have. Which is 8. And my units were in length, so I had meters. So my answer is 8 meters. And now I'm going to perform the standard algorithm, because the solution to that should really support the result I got from my drawing. And I have here 12 divided by 1.5, and I'm going to turn both my whole numbers and my mixed numbers into improper fractions in my first step before I actually apply the algorithm, which is to skip the first number, change the sign, and use the reciprocal of the second number. I get 24/3. I need to remember that that fraction bar also means divided by. I get 8 meters, and I see that my solution, while using the standard algorithm, is the same as the one I got from my drawing. And there you have it.